Hi, welcome to this video on principles for designing charts. So let's start by talking about what graphical displays do, right? The main purpose for graphical designs in literature is basically to show the data, right? We want the graphical displays to induce the reader to think about the substance rather than the graphical design. Okay, this is important. We want to use the graphs to help the reader understand the data, right? Not admire how beautiful the colors are. Graphical displays should avoid distorting what the data has to say. They should present the numbers in a small space. That's why you're using a graphical display. Also, they should make large data sets coherent, encourage the eye to compare different pieces of data, right? And serve one reasonable, clear purpose, right? Either to describe data, to explore data, or tabulate data, or decorate, right? They should serve one of these purposes. Don't try to decorate with a tabulation, or try to explore, describe, and tabulate and decorate at the same time, because you will get into what is called a lot of chart junk that we're going to discuss in a minute. Alright, so there are two main principles that you have to always have present when you're designing a chart or a graph. When you've decided you want to include a chart to present some data, there are two principles. One, that the chart should have graphical integrity, right? That means that the chart is telling the truth about the data, that you're not lying with your chart. And two, that your chart is efficient, has an efficient design. That means that it gives the viewer the greatest number of ideas in the shortest time, with the least amount of ink, and in the smallest space possible, right? So a good chart, right, the best charts are those that have integrity, that is, that they don't lie, and two, that they are efficient. Now let's explore each of these principles. So for graphical integrity, right, that means the charts should tell the truth about the data. And there are two things that may lead you to lie with charts. One is quoting the data out of context, right, or hiding some data, right? That is also a way of taking the data out of context. And the second one is that the representation of the numbers as physically measured on the surface of the graphic itself should be directly proportional to the numerical quantities represented. Now this is easier to explain with an example, and we will do just that. But first let's start with graphical integrity, right? A graphic should not quote data out of context. I'll give you an example of this. Let's suppose we're showing we want to show the growth in our clients, right? And we decided to show 2 points in time. Here we're showing that in 2006 I had 100 clients, and in 2009 our agency had 150 clients. The line is showing a great increase, right? A 50% increase in clients from 2006 to 2009. Now, we're showing 2 points in time. But suppose that we are omitting other data that we have that would bring context to this growth. Right? Now, let's suppose we add 1 year of data and 2 more agencies. Right? Now, these are the 2 points that are represented on this one. Right? Now, we chose to not show 2012, and in 2012 we have a drop, right, into 100. So from 2006 to 2012 we have actually no growth at all. We have a decline from 2009 to 2012, and the other agencies are showing constant increase, in their numbers, right? Now, this is lying by omission, right? We could have provided context to this data, right? We could have provided all the data, but we chose not to do it on this one. So this chart is actually lacks integrity, right? It's lying by omission. Okay, so it is your duty as a researcher to be not only vigilant about charts that you see that may be lying by omission, but also to produce graphs with integrity, right? Present all the data, present all the context that you can along with your data, so that the reader can make their own conclusions. The readers. Okay, the second type of visual lies is lying. Or it's lying with with proportions, right? Let me show you that with an example. Here we have a number of clients served by my agency from 2000 to 2010. In 2000, let's say that our agency served 200 clients. In 2005, it served 300 clients, and in 2010, it served 400 clients, right? So we have an increase of that the agency doubled in size. But I want you to look at the area in these bubbles, right? This bubble is representing 200, and this bubble is representing 400. Do you see anything wrong with that? Right? Well, many things are wrong with that. The proportion of this bubble, the 400, right, or the size of this is out of proportion with this one, right? The numbers are showing 100% increase, but this bubble is many times larger than that, right? This bubble should only be twice as large as this one, but it is a lot larger than that, right? We're creating an illusion here just by using a larger area of a greater change than what it is, right? It's showing an illusion that because the area is much larger than that, our eyes are telling our brain this is a huge increase, but the numbers are not showing what the areas are, right? So this is a visual lie that you're using. Now, I've seen these types of graphs many times. Most of them fall into this onto this error, right? The proportion does not match the actual numbers, and that is a visual lie. So be vigilant about that, and also make sure that you do not fall into that mistake. This is another typical trick to show big differences. Let's try and see what this graph is showing. Okay, so this is the percentage of clients who report being happy with my agency. This is the percentage in 2008. Let's read this. 20%. In 2008, 20% of clients rated or were very happy with the agency. In 2013, the number is 25%. Yes, 25%. Now, this is a huge difference in the graph, right? The numbers are just showing a 5 percentage point increase. But the areas, right, this guy is a lot larger than that. Certainly larger than just 5 percentage points. Right. So the proportion of the size of the bars is not proportional to the what the numbers are saying, right? The percentage difference between them is only 5 percentage points, but this bar, right, is 3.5 times larger than this. Right? The area here is 250% larger than that one, but the number, the actual numbers just show a 5%, 5 percentage point difference. If we would change this scale, things will look like this, right? If we're going from 0 to 100, now they are in the same scale, and this is the difference, right? Just the 5 percentage points, and it's showing that actually not many people are happy with the agency, right? It's just 20%, and here it's just 25%. There is an increase, but it's a small increase. And on the overall scheme of things, people are not very happy with the agency. But if you see this, you think that there was a big increase, and this is also very close to the top, right? So it is. This is typical. This is typical lie of people who want to show a big change and a big difference. So be vigilant about that, and of course, don't use this type of lie. So that's chart integrity. When your graphs want to have integrity, you want to have integrity when you're creating graphs. To do that, two things: avoid lies by omission. So show all the data you have. Do not quote data out of context. Right? And two, avoid visual lies. Right? The chart areas should be proportional to the figures shown in the chart. Right? So the next video is going to talk about the graphical design, right? So don't miss the next video. I'll see you in a little bit.